Hi everybody, it's Miss Jackson. I'm going to walk you through the electron configuration notes for this unit. Much of this you will have covered in some of the preview videos, but I want to walk through the notes and be sure that you have everything in your note guide that you should. So as we start off, let's look at our periodic table. In the previous activities that you've completed with a periodic table, you should have learned that your periods are going horizontally across, right? And so our rows are the periods of the periodic table, and our columns are the groups and families. So as we start looking at electron configuration, it's really important that you remember that your rows going across are the periods, and they are going to have special significance for our electron configurations because those are going to represent our principal energy level. So when we start looking at electron configuration, really all we're looking at is trying to identify the location where all the electrons are around the nucleus of an atom. So if I have the nucleus of an atom, and I'll pick up a pen. If I have the nucleus of an atom, an oversimplified way to look at it is my nucleus is in the center and my electron energy levels are surrounding that nucleus, okay? Each one of these energy levels that I'm drawing around the edge of my atom okay, represents an energy level from the nucleus. So this is energy level 1, this would be energy level 2, this would be energy level 3. Now again, this is overly simplistic, but it's going to get our conversation started. And each one of these principal energy levels corresponds to a row on the periodic table. All right, and they just really tell us how far the electrons are from the nucleus of the atom. And within each one of these energy levels, we have sublevels. All right, so that's actually number 3. The sublevels that we talk about on the periodic table are within each energy level, we have different sublevels. So if we look ahead to the next slide, oops. Okay, our sublevels are the S, the P, D, and F block. These are all on your note guide. They are on the back of the front page, but these represent the different sublevels where our electrons may be found. So for each energy level, we have sublevels. This is energy level 1. I have sublevel S. Energy level 2, I have sublevel S, and I have an energy level 2P. On energy level 3, we have an S, we have an energy level 3P, and we will get down to our 3D. So within each energy level is a sublevel, and those really represent within the energy level where the electrons are. It's a little bit like the video that you saw that describes seating at a stadium. If you're trying to find your seat at a stadium, you have a section, you have a row, and you have a seat. And this is very similar. In concept. We're just trying to identify where the electrons are located. When we look at our sublevels, the S, P, D, F, those really just correspond to different regions on the periodic table. The S block are the first 2 columns. The P block are the 6 columns on the far right. The D block is down in the dip, and the F block lies far below. All right, so those are your sublevels, and each energy level has sublevels. Within each sublevel are a specific number of orbitals. So the S sublevel, those that are located right here, so this is the S sublevel on our periodic table. These first 2 columns are the S sublevel. Those are the S's. And they have a spherical shape. So you can see right here, there's an illustration. They're spherical in shape, very simple, very low energy. They get what's called 1 orbital. Within each sublevel, you get orbitals, and they each have their own unique number. S sublevel has only 1 orbital, and it will hold 2 electrons. So the most electrons you can put into an S is 2. So this is my S sublevel, and there's my first and my second electron. For the P sublevel, these are illustrated below. These are called dumbbell shaped. Sometimes you will hear them called peanut or propeller shaped. But the P sublevel, a little bit more complex, okay, with its 3 different orbitals. So it's got the shape of the infinity sign or of a propeller or called the dumbbell. And there are 3 orbitals within the P. So you've got one going horizontally, you've got one going vertically, and then you have one that would be coming out of the paper towards you. So kind of those 3 dimensions that you learned in geography, X, Y, and then you've got the Z plane coming out at you. So because each one of these orbitals holds 2 electrons, if I can put 2 electrons in the first one, and 2 electrons in the second, and 2 electrons in the third, that gives me a total of 6 valence electrons. And so that is what I see on the right-hand side with my P sublevel. So this is my section of the periodic table that is the P. Oops, I got off. This is the P block. 1, 2, 3, 4, 5, 6 electrons total. The D and the F sublevels have really complex shapes. So what you need to know about the D sublevel is it's got 5 orbitals. This is the D block down here in the center. I call it the dip. So you've got the D sublevel here, right here in the dip. And then down below, you've got the F. So this is the F sublevel far below. And so we're going to use this idea of these different areas of the periodic table, these different blocks, to start identifying where the electrons are located, okay? When we start talking about the orbitals, right, the orbitals hold 2 electrons. What you need to know is they will have to spin in different directions. So for example, here on number 4, the spin of the electrons have to be opposite, which is illustrated with arrows that point in different directions. The first one points up and the second one points down. So you can see that for the first energy level, S sublevel, it holds 2 electrons, one points up and one points down. For the second energy level, so we're looking at the second energy level, the S sublevel, so these 2 right here, that's 2s. One electron spins up and the other electron spins down. When I get to P, you'll see in this illustration there are 3 different boxes. That represents the 1, 2, 3 different orbitals for the P. And I can put 2 electrons in each box, and I will put 1 in each box, and then I will partner them up. We'll talk about that more in just a second. So let's start looking at our rules. The first rule that we're going to follow is called the Aufbau principle, and that means we're going to start building from the lowest energy level up. So when we look at our atoms, okay, all of the atoms that we're going to look at have the same electron positions around their nucleus. What determines which of the positions or seats are filled is how many electrons the atom actually has. So they will start putting them into the lowest energy seats or levels, and then they'll build out. So they go low energy to high energy. That's the Aufbau principle. We'll talk about these other 2 principles, the Pauli exclusion and the Hund's rule, here in just a minute after we've done a little bit of work with our configuration. So let's start looking at how we begin to write an electron configuration. So let's look, for example, at a simple one. I'm going to save these examples for just a moment, and I'm going to help you through a couple of examples. So let's go ahead and let's start with hydrogen. Let me come over here. Let's add our periodic table here. Let's just move that up here. We're going to look. This periodic table is nice because it's got the S's, the P's over on the right, the D's in the dip, and the F's far below. So let's start looking at the simple configuration for an element of hydrogen. So we've got an atom of hydrogen. Okay, hydrogen is located right here. It has 1 electron. So I'm going to put that electron in the lowest energy spot. The lowest energy location I have is energy level 1, sublevel S, and I have one electron that I'm going to put there. So hydrogen's electron configuration is energy level 1, sublevel S, one electron goes there. And that's all there is for hydrogen. He's very simple, he's very small, one simple electron. And we're going to repeat this format as we build our electron configurations. We're going to have our principal energy level. That is terrible. That is even worse. So, energy level 1, we're going to our principal energy level. So that's going to be the first thing that our symbol has to have is the principal energy level. And that corresponds to the row. The next part of our symbol is going to be the sublevel, and that's going to be, it could be an S, it could be a P, it could be a D. I'm going to use an X just as a generic fill-in variable because it could be S, P, D, or F. So this is going to be my sublevel. And then I'm going to have a superscript that I write at the top that's going to give me the number of electrons. And that's what's going to be written to the top right of all of our symbols. And this is going to be the number of electrons. First thing that we write is the principal energy level. That's the number. Then we tell the sublevel, and then we show how many electrons are written there. So for hydrogen, when we looked at hydrogen, he has one electron. It's in the first energy level. It's located in the S sublevel, and I have one electron written there, or I have one electron showing. And we're just going to repeat this for every electron that an atom has. Now this does usually take several examples before you start to see the pattern, so don't panic. All right, let's look at helium next. Helium is element number 2. He's got 2 electrons normally. So helium is over here. So he's kind of a weird one. So let's go ahead and tackle helium. Helium is still on energy level 1. So my energy level is the same. But even though he's pushed all the way to the right, he really belongs here. He belongs in both places, but he fits the noble, he's a noble gas by definition, and so we put him with the rest of his family on the right-hand side. So he is still energy level 1. He's actually sublevel S, and he has 2 electrons to put there. The first seat was taken up by his first electron, and then he puts his second electron in the second spot. Okay? So he has 2 electrons filling his S sublevel. All right, hang with me. I know it gets a little strange. I know it seems really strange, but eventually you will see the pattern, and it's like a switch. It will click on at one point, and you will remember, you will know how to do it. So just hang with me through several examples. All right, let's go down to the next row. All right, I'm going to read my periodic table the way that I read English. I read from top to bottom, and I read from left to right. Once I finish filling in electrons on my first row and I get to the end, now I have the ability to bump them out to the next energy level. So lithium, for example, has 3 electrons. Okay, so for lithium's electrons, again, he has to start from the inside out and he has to fill all the energy levels. So if lithium is sitting right here, okay, with 3 electrons, the first 2 that he has have to go at the lowest energy spots, and that's energy level 1. So he starts filling in his electrons on energy level 1, sublevel S, and he's able to put 1 and 2 electrons there. When we're filling in our electron configuration, every one of the boxes has an element symbol in it. But you need to remember that that element symbol, for example, for lithium, simply is where lithium's last electron is. So if his last electron is here on energy level 2, all of the spots below it must have filled in. So he has 2 electrons on energy level 1, sublevel S, but he is now filled his first energy level. So he has to take that 3rd electron and he's going to put it on energy level 2. He's going to fill it into sublevel S because I'm in sublevel S, and he has 1 electron that he's going to put there. So I'm really just building my electron shell 1 electron at a time. If I want to double check myself to see if I've done them correctly, or at least have the right number of electrons, if I take my superscripts and I add them together, it should match the number of electrons I was hoping to find. So lithium has 3 electrons. 2 plus 1 is 3 electrons. So let's do several more. I'm going to continue and do several in a row. I think it helps you to see them a little bit more than skipping around. Once we get going, I will be able to skip around just a little bit. So the next one I want to cover is beryllium. He's next in line. Beryllium has 4 electrons. So just like all the other atoms, he starts filling in his energy levels from the ground up. So this is my first energy level and I have to fill it. So beryllium says I have 4 electrons on energy level 1, sublevel S. I'm going to put 2 of them. And that fills up my first energy level. Now I'm going to start putting my electrons onto the second energy level. I'm going to fill them into the sublevel S. I'm just reading the periodic table, and because I come to the S sublevel first, I know that the electrons go into the S sublevel first. And then I count over the number of boxes, 1, 2, and so beryllium has 2 electrons in his 2s. I add the 2 plus 2, and that does equal the 4 electrons I was looking for. Okay? So let's create another slide and let's do several more examples. All right, so we've done through beryllium. Now we're going to look at boron. So boron has 5 valence electrons, or 5 total electrons. So he's got 5 total electrons, and we're going to do exactly what we've done before. We're going to start filling in from the lowest energy level and build out to where boron is. So boron is right here, and we're going to fill in the electrons into the lowest energy levels and build out. So the first electrons go into energy level 1. They go into sublevel S. There are 2 of them. 1, 2 spots. Now boron has filled in his first energy level, and he gets to start putting electrons into the second energy level. First sublevel I come to is energy level 2, sublevel S, and I'm going to put 1, 2 electrons in the S. And 2 is all that the S electron or sublevel holds, so that's all I can put there. 1, 2. But boron has 5, so now I need to start adding in the next available block. So I am still on energy level 2, but now I've moved out of the S block, and these are my P block columns. So energy level 2 in the P block, boron is in the first box, which means his electron goes into the first spot. If I double check myself by adding up my superscripts, 2 plus 2 plus 1 is 5 electrons. Now we're going to look at carbon. So carbon I've got started here for us. Carbon has 6 electrons. The first 2 electrons he puts in the first energy level, S sublevel. He puts 2 electrons there. Then he's filled up energy level 1. so he goes to energy level 2. In the second energy level, in the S sublevel, he puts 2 electrons, 1 and 2, but then he's got to go over to the second energy level, P block or P sublevel, and he's going to fill in 1, 2 electrons in the P sublevel. He can't go any further because 6 electrons was all he has, and if I add up my superscripts, I've got 2 plus 2 plus 2 are the 6 electrons in carbon. So let's do a couple more. Let's look at fluorine. So now we're going to jump a little bit. So fluorine, symbol F, not FL, just an F, has 9 electrons. The first electrons go into the low energy level 1, sublevel S, and I can put 1, 2 electrons there. But then he's filled his first energy level. So now he starts putting electrons onto energy level 2. So energy level 2, sublevel S, because that's the first block I have to cover. I put 2 electrons there, 1, 2, and now I'm moving over into the 2P block. And I count over 1, 2, 3, 4, 5 to get to fluorine. So fluorine ends with 2p5. When I add my numbers, 2 plus 2 plus 5, it equals 9. So now let's go back and look at some of your practice from your notes. So on this one, we're looking at the configuration for germanium. So I'm way down here in germanium number 32. Okay, so when I look at germanium, I'm going to have to work a little bit further out, which means I'm going to have to cross the D's down in the dip. Well, if I look at my notes, okay, my electron configurations work just like they should. I move from 1s to 2s to 2p. The only thing you have to remember when we start adding in the D blocks is that because the D is such a complicated shape, I actually am going to fill in the 4s and then I fill in my 3d. It has to do with the shapes and the energy of the orbitals. S is super simple and it's lower energy. Even though it's farther away from the nucleus, it is a lower energy. So I fill in 4s and then I do 3d. So let me show you how that works. So if I'm looking at germanium, okay, so germanium has 32, energy level 1, sublevel S, I put 2 electrons. This is going to be exactly the same as we do all of our electrons. Energy level 1, sublevel S, 2 electrons, boom. Then I have finished my energy level 1, I move to energy level 2. So on energy level 2, sublevel S, I put 2 electrons, there's 2 more, sorry, sublevel S. Now I work my way over and I'm to the second energy level. I am in the P block and I'm going to fill all these up. 1, 2, 3, 4, 5, 6. So I put 6 electrons in the P and that finishes this row. But I have more electrons, so I go to the next row. So now I go down to sodium, or I'm sorry, the third energy level. So third energy level, the first sublevel I come to is S. I fill in those 2 spots, so 3s2. And then I have to move over to what's called the 3p. See the pattern? I'm filling in 3p. And I have to fill in all those boxes. 1, 2, 3, 4, 5, 6. I'm just filling in all the spots until I get down here to germanium. So I filled in 3p6, but I'm not done. So now I come down to the 4th energy level. energy level 4, sublevel S. I fill in those two boxes. So 4s2. And then I just keep moving across. I just have to remember when I get to this first block of the D's, this is 3D. So I am now filling in 3D, and I fill in all 10 boxes. All 10 seats get filled. Because remember, I'm trying to get over here to germanium 32. So I've filled in 4s, 3D10, and if I go back and I look, once I fill in 3D, I'm moving back over to 4p. So when I look at germanium, 3D10, 4p, and I'm 2 boxes over. All right. Now we're going to look at chlorine. Chlorine, a little bit smaller. Oops. I'll fill it back in for you. Chlorine is a little bit smaller. I'll fill this back in for you. So that was 3D10, 4P2. Now let's look at number 4, chlorine. Chlorine is number 17. He's right here. He's actually a little bit easier than the last one we did because he doesn't go so far. So chlorine, energy level 1, sublevel S, 2 electrons. So 1s2, done. Then I'm on energy level 2, sublevel S, 2 electrons. Energy level 2, sublevel S, 2 electrons. Then I move over. I'm still on energy level 2, but now I'm in the P block, and I'm going to fill all those boxes, so 6. So 2p6. Then I get down to energy level 3, sublevel S. I put 2 electrons there, and then I move over. I'm still energy level 3, but now I'm in the P sublevel, and I fill in 1, 2, 3, 4, 5 boxes to get to my chlorine. Okay, now that we've looked at how to write some of the long electron configurations, we're going to look at what's called the noble gas notation or the abbreviated notation. So hopefully you have noticed as I've gone through the examples that they all start out the same. 1s2, 2s2, 2p6, 3s2, 3p6, so on and so forth. So we're going to utilize this idea and we're going to come up with a shorthand way to write our configurations. So let's look at an example for our shorthand configuration, and let's start by looking at phosphorus. So phosphorus is element 15, so he's got 15 electrons. His configuration is 1s2, 2s2, 2p6, 3s2, 3p3. But when I look at that, if I look at where phosphorus is, I can see that I have come down, I have filled 1, 2 full shells. So what we're going to do is we're going to use this family of noble gases as our measure of a full shell. So when I look at my configuration for phosphorus, I can see that if I look at 1s2, 2s2, 2p6, that's actually representing a full configuration all the way through the second energy level. If I look at neon right here, neon's configuration is 1s2, goodness sakes, is 1s2, 1s2, 2s2, 2p6, and that's where neon sits right here. So our noble gas notation is simply finding the last noble gas that we went by and using its symbol in brackets. So notice 1s2, 2s2, 2p6 is the same as this part of phosphorus. So what we're going to do is we're going to put that in brackets and say, hey, up through neon, everything is full. And then all I have to do to get to phosphorus is write whatever remains. So up to neon, I was full, and then I filled in 3s2, 3p3. And that's the shorthand way to write that. So in this case, we saved ourselves writing all of 1s2, 2s2, 2p6. I can replace that with the sign symbol for neon and then 3s2, 3p3. So now you try it for sulfur and vanadium. Pause the video and try it for sulfur and vanadium. Okay, so for sulfur, normally I would write 1s2. Normally I would write 1s2, 2s2, 2p6, 3s2, 3p, and then I would write 4. But when I look at sulfur, I want to write the noble gas configuration. The last noble gas that I went by to get to sulfur was also neon. So if I look, just like I did on the first example, this 1s2, 2s2, 2p6 is the configuration for neon. So for sulfur, I put neon in brackets, and then I simply write whatever's left. 3s2, 3p4. Vanadium is going to work in a similar way. So I'm going to look at vanadium. If I write the full configuration, he's right here, number 23. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then I have to remember that the D's are one level off, so this is 3d, and I count over 1, 2, 3 boxes. But if I want to write the noble gas configuration, the shorthand, I come back to my table. If vanadium is 23, the last noble gas I went by was argon, and that was the last shell that I filled. So this part of the configuration is the same as argon. So what I do is I simply put the symbol for argon in the brackets, and then I fill in 4s2, 3d3, and that's the noble gas configuration. And it's a shorthand, so it's really nice and trim. It makes it a lot easier to write some of the larger configurations. So I hope this helps with your configurations. Be sure and come back and watch the video on writing orbital diagrams. Thanks. Bye.